Generally, electricity generation is one of the main contributors of carbon dioxide. The graph displays the carbon dioxide emission from different resources in Malaysia. Can be seen that in 2015, more than 50 million tons total carbon dioxide emitted in Malaysia came from electricity generation. Based on the statistic published by Asian Pacific Energy Center, carbon dioxide emission from energy consumer expected to grow about 4.2%, reaching to 414 million tons of carbon dioxide in Malaysia. Apart from that portion, buildings are responsible for 40% of the total annual energy consumption, with major percentage of the energy is used for heating and cooling applications. In general, the major effect of this phenomenon is most on climate and health. The problem is the total carbon dioxide emission in Malaysia is getting higher, especially from electricity generation, and we need to find a way to reduce it. Thus, the solution that we prepared is to develop an environmentally friendly energy harvester. Some examples are geothermal energy, wind energy, biomass energy, solar energy, tidal and wave energy. Each of these energies has its own drawback that it needs a new alternative energy harvester. The finding of new way of alternative energy sources, an idea has been proposed, which is by using the phase change material. The phase change material is a renewable energy and does not emit carbon dioxide or with the minimum amount. Moreover, the source of energy is heat, which is not limited to the sun. The living space without air circulation also can be assumed as heat source. Furthermore, the maintenance cost for PCM is low because the lifetime of PCM is unlimited as long as it does not expose to the moisture and the working temperature is within the melting point. PCM use latent thermal energy to store energy through phase change of the storage medium. It makes use of the latent heat of a phase change between the solid and liquid state. In addition, PCM is a substance that melts and solidifies at a certain temperature by absorbing and releasing large amount of energy. By implementing that theory to the system, during the day, the hot air in living room will pass through the PCM storage system. The PCM will absorb the heat from the air, then change its phase to liquid. The air will be cooled and delivered back to the living space. Complementary to this, at night, the absorbed heat will be released back to the environment that makes the PCM change from liquid to solid. The released heat then is called as waste heat. That waste heat will be collected and converted to electricity using thermoelectric. For this project, the innovative element is instead of releasing the waste heat to surrounding, the waste heat is accumulated and converted to voltage. The voltage generated then can be used to power up the electrical appliances.
The prototype setup for this system including a box with two partitions. The two compartments are divided with an adjustable divider, which one side is for heating process and the other side where the PCM was installed. Before the PCM absorbs the heat, the room will be heated up for 3 hours. Then the barrier will be lifted up for another 3 hours to expose the heat to PCM. The reading was taken 8 hours with the balance 2 hours where the heater was turned off. The intention of doing so is to measure the maximum heat absorbed by the PCM. To measure the temperature changes within the box, temperature sensors were placed in both compartments. This absorb and release heat process will be monitored using Keysight V. Nonetheless, this system is not only applicable for indoor application, but it can function also for outdoor application. With this advancement, it can be placed in rural area without electric supply, for example, street light. This street light can be a light source for the kids to study at night. In the same way, it also can reduce electricity generation demand in future. The development of energy storage building is a solution to the ongoing quest for energy conservation and also to improve the indoor environment in which people work and live. Nevertheless, with the reduction of CO2 emission, providing a safe environment also healthy air circulation for the next generation.